guys, this lesson is on section 1.5 and I'm going to jump right in. It's on personal expenses, but I'm going to at least be utilizing my scientific calculator. I don't know what kind of calculator you're using, but hopefully has the ability to do these sorts of things. So we're going to jump right in. It has some vocabulary in your book. So for example, by variate data is the first vocab that I want to point out. Shows a relationship between the paired numbers. And by variate, that means you have two. The word by, like bicycle, refers to two, or binomial all refers to two. And there are two types of variables that they discuss in this section. Your explanatory and your response variable. Explanatory is x, and this is the variable that causes the change. Your response variable is y, and we call this the affected variable. Oops, I was about to write affected twice. Affected variable. Okay, so those are the two. There's bivariate data, explanatory, response. The next thing I want to point out is a scatter plot, and we'll be building several of these. A scatter plot is a graph that shows bivariate data using points. Okay, so we are going to be asked in our homework and on the test to build a scatter plot. Sorry if that cut off. And the last vocab I'm going to go over for now is correlation. And think of correlation as the relationship between two variables. And you can have two kinds. You can have a positive correlation or you can have a negative correlation. And so I'm going to go over the two because we're going to be talking about these both. So a positive correlation is when a relationship is a relationship in which they're both increasing or they're at the same time. For example, a positive relationship is when x is increasing and so is y. So I'm just going to put when both variables increase. So both values are going up. A negative correlation or a negative relationship is when one is decreasing and the other increases. So negative would be if they're moving in the opposite direction. One value is getting larger and the other value is getting smaller. Okay? So I'm going to draw a picture of each type of correlation in our first example. So in the first example, in which you'll see in your homework, determine the type of correlation that each of these has. And so I'm going to draw three different pictures in part A, B, and C. So in the first picture, I'm going to draw just kind of random. They won't be in a perfect straight line. And last and C. All right, so let's look at, sorry that this one is slightly crooked. Let's look at A. We always read our graphs left to right, just like we read our words. So starting on the left, I notice that this graph is moving down, okay? And I also notice that these values are starting larger and getting smaller as these values are getting larger. So just by looking at this, looks like a negative slope. So I would say that this has a negative correlation. My values are decreasing over time. Now notice the dots don't form a perfect straight line, and that's fine. You're looking at the overall look of it. So if you look in part B, if I read this starting on the left, my graph is positively moving to the right. And so this is an example of a positive correlation. C is neither moving up nor down. It's almost a flat line, a straight line, and so I would say that this has no correlation. So remember, it won't be a perfect, like the dots aren't going to form a perfect line, but you're kind of looking at it overall, okay? And the last thing we need to cover is that there is going to be a letter that represents correlation, and we're going to be able to determine that in our calculator, and that's called, I think I wrote, I want to make sure I wrote it the same as the book did. I think I wrote, there's the correlation coefficient. So correlation coefficient, we can actually calculate the actual correlation of something, and it's going to be, it's going to use the symbol R. Okay, so that's the letter that will be in your calculator and in this book. R represents the correlation coefficient, and R is, or should be, is between -1 and +1. -1 would represent a negative correlation, right, because it's negative. And the closer you are to +1, that would be a positive correlation. So we're going to practice describing something based on the correlation coefficient. And we're going to describe things as either weak, strong, moderate, positive, or negative. So here's our second example. We're going to describe each correlation coefficient using the following terms. So using terms, we'll use strong, moderate, weak, positive, negative. So I'm going to give us several, A, B, C, D, E, F. And I'm going to give you the coefficient, the correlation, which is R. So in the first one, R equals -0.19. B, R equals 0.93. In part C, R equals 0.57. In D, R equals 0.099. In E, R equals -0.97. And F, R equals 0.45. And sorry, that should be negative. Okay, so if you have a hard time reading decimals, I want you to think that, read it as money. So this would be a negative, you can ignore the 0, so this is -19 cents. So -19 cents, is that close to, I know it's negative, right? I know it's negative, but we're going to describe it as either weak, moderate, or strong. Now, is this closer to 0 or -1? Think of 19 cents. Is that closer to 0 or 1? That is closer to 0. So this would be a weak and negative correlation. All of these have the word correlation, but I don't want to write it every time. But each of these will have that word. The next one is positive, right? This is a positive number, so I know it's positive. And 90.93, think of that as 93 cents. That's almost a full dollar. So I would say that this is a strong positive correlation. Okay. In part C, again, this is a positive decimal, so I know it's positive. And then I have to talk about whether I think it's weak, strong, or moderate. Now, think of that as 57 cents. 57 cents is basically in the middle of having 0 or $1. So that's where the word moderate, it's right in the middle. So think of middle as moderate. Okay. Part D. So I know it's positive because there's no negative here. Now 0.099, that's a little less than 10 cents. 10 cents is almost 0. So I would say that this is a very weak positive correlation. It's hardly 10 cents. Almost, right? If I was to round 0 up, it would be 0.10. This next one, I can see by the negative sign, this has a negative correlation. But 0.97 is almost -1, right? It's super, super close. So I would say that this has a strong negative correlation. At any point, you can pause this and then check your answer. So what would you write for part F? Pause it, write your answer, and then push play to check mine. I am going to say that this is a moderate negative correlation because it's basic close to 0.5. I know it's negative, but 45 cents is close to 50 cents, so it's right in the middle. Middle is moderate. Okay? So, moving on, we're going to do some actual examples, and I didn't want to have to write a bunch of word problems, so again, you can print this out. You are welcome to print out my notes, but I have just typed up the problem so that you and I wouldn't have to write a million words. So I'm going to tape that down, and then I'm going to go over it. So, this says each month you have $200 automatically deposited from your checking account into a savings account. Your plan is to leave the money there. So you're going to deposit $200. I put tape on this. So $200 a month for the next 10 years in order to use it at that time. A scatter plot shows the number of months that have passed. So X is number of months. Y is the amount of money. So this is asking us to, the response variable is, so I know that this is response. This is explanatory. And they're simply asking, does this have a positive or negative correlation? So that's all they want to know. Is it a positive or negative correlation? So if I'm depositing $200 in the bank every month, is the amount that I'm putting is the amount of money in my bank increasing? Yes. So the answer would be that this has a positive correlation because both amounts are increasing. The more time that goes by, the more money in the account. And that was really all they wanted. Homework and the test might give you different scenarios, but because they're both increasing, notice I put more time is more money. So they're both getting more, so they have a positive relationship. Okay. Next one, so number 4. And I have some data for you, and this represents movie play, online movie rental service. Okay, and so this table represents the price of a rental and how many people actually rented it. So anytime they give you a table, pretty much think of the first variable as x, right? This would be x. And this would be y, just like we set up our tables. So x is our price, and the number of rentals is y. So what do we notice about this? Okay, do we notice that this is positive, negative? So that's going to be part A. Describe any trends that we see. So when I look at this, I look at, okay, at 99 cents, 1,900 people rented it. At $1, a little less. $2.99, a little less. So the more expensive, the less people rented it. So the more expensive the rental, the smaller amount of people that rent it. So just from observing, I think this has a negative correlation because as one value, X, gets bigger, Y gets smaller. X is increasing, Y is decreasing. So the next part of this problem is we're going to make a scatter plot. Now you can use graph paper, you can use your lined paper, but I'm going to go ahead and set it up. And I need, let's see here. I need 400, 800, 1200, 1600. Okay, so I'm going to make the top one 2000 because it's close to 1903. And I'm going to make this first one 400. So I'm going to go by every 400. So 400, 800, 1200, 1600. Remember, the number of rentals is Y. So this is number of rentals. Down here should be our price, which is the amount of money. So this is X. Sorry, I'll move that up. And so I'm going to round. I'm going to just make 6 of them, right? 1, 2, 3, 4, 5, 6. So this is 2, 4, 6. Now, when I plot these points, I'm going to round, I hope you don't mind, like $5.99. I'm just going to plot that as 6. So I'm going to start at the top. When it was almost $6, I'm going to go 800 people rented it. $4.99 is basically 5. When 5, right halfway between 800 and 1200 would be 1,000. So about 5, there was about 1,000 people that rented it. $3.99 is basically 4, and when it was $4, 1,200 people. $2.99, that's basically 3, and this is $13.80. Well, I know I went by 2, 4, 6, this is 200, 400, so every half space, so however you want to do that. But at almost $3, I had almost 1,400. At $1.99, I had a little over 16. And at $1, almost 2,000. So just looking at that confirms my negative correlation. Okay? And then part C, estimate the number of rentals for a price of $6.99. Okay, so I'm going to look at my table, and I noticed that, do you notice the difference between these last 3? Like when it was $3.99, it was $1,200. When it was $4.99, $1,000. When it was $5.99, $800. Notice these are all decreasing by 200. So the logical guess that would be that the next one is 200 less than 800. So I'm going to guess, I would take that last one, and I'm going to guess it'd be 200. So I would guess that there are only 600 rentals. Remember, we're estimating, but we want to look at our table and go from that. Next one is we're going to actually dive in to some actual problems. Well, I'm going to give you one other real scenario. So let's say my explanatory, no, I'm not going to do that one. We don't need another one like that. All right, so the next part of this chapter goes over something called linear regression. And I'm going to show you how to do this in the calculator. If you want to use Desmos, you can use Desmos, but either one is easier than doing it by hand. So when we do linear regression, we're looking for a line of best fit. And it's going to be linear, so because it's linear, the form is y equals mx plus b. Now, so remember slope, m is slope, b is y-intercept, but we're going to find all of this in my calculator. So in my calculator, the one I'm using, I'm going to go to statistics, and I'm going to select two variable, and it's two variable because I have x and y. So I'm going to show that to you in my calculator. Remember I told you to get a scientific calculator. So if I click if I click I have to shift stat, and I had to shift because the stat word is in yellow above the button, so you have to second stat. And then notice I have one variable, two variable, so I need to select two variable data and hit enter. The next thing I'm going to do is I'm going to enter my data. So I'm going to enter all x and y values. And then finally, I'm going to hit stat variance, and it's going to calculate A, B, and R. A is m, or slope. B is what it says, it's your y-intercept, and R is your correlation coefficient. So we are going to practice that using a problem that I got. So I believe we're number 5, and I'm going to give you a table of data, and we're going to do this in the calculator. I'm actually going to move this over. All right, so when I look at this, I have the years and the amount of money spent for back to school. Now I know this is going to be X, and this is going to be, this table here is going to be Y. I also, even though this says 2004, often when we're using years, I'm not going to actually enter 2004. I'm going to say, I'm either going to enter this as 4, or this is the first year they listed. So in the calculator, I'm going to put that this is year 1, which would mean this is year 2, year 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And sometimes in the directions of the problem, it'll tell you that. It'll tell you to use 1 for 2004. So the first thing I'm going to do is determine linear regression by finding the equation, linear regression equation that best fits the data. So, grabbing my calculator, the first thing I'm going to do is hit the data button, and notice x1. So that means the first x, so I'm going to enter 1. And then it's going to ask me for the first y value, and I'm going to enter 483.28. And then I'm going to use the arrow button to do the next one. So 2, arrow down, the next value is 443.77. And I'm just going to keep going. The third value happens to be a 3, and the next value of y is 527.08. Next, 4, y is 563.49. Next, x is 5, y is 594. Enter them very carefully. When x is 6, y is 548.72. Next, when x is 7, y is 606.40. Next, when x is 8, y is 603.63. Next, 9 and 688.82. Next, 10, 634.79. Next, 11, 669.28. Next, 12, and 630.36. Now, did that take me a while? Yes, but way less doing it with a calculator than by hand. Also, just by looking at this, x is getting greater, so is y. So it's going to have a positive relationship. So after you enter the data, then hit stat variance. It literally says STATVAR. It's calculating it. Now I have to move my arrow button all the way over till I get to A, B, and R. So notice A, I'm going to round to the nearest tenth. So 8 rounds that 8 up to 9. Then I'm going to scan over to B. B is 466.6. 9 rounds the 5 up. And then last is R, which is point. I'm just going to go ahead and record this 0.88, and I'm going to keep it at 0.88. So I'm going to write my equation. So my equation would be y equals A times x plus B, 466.6. So there's my equation. B, what type of correlation is this? I would say R is 0.88, so that is a strong positive correlation. Okay? And then using our equation, whoops, or maybe I should do that, A, B, C. Using our equation, to predict the spending in 2016. So, I have a nice equation and I'm going to use that. But first, I'm not going to enter 2016. 2016 would have gone right here, which means that x would be 13. And then I'm going to plug that into my equation. So y equals 17.9 times x. So I'm going to put 13 plus 466.6. So y equals $699.30. So that's a prediction of how much would be spent in your 13th year in family. So maybe they're going to college. That's why it got a little bit more expensive. All right, last one. So I believe this is number 6 for us. Or did I do another one? No, this is it. So last one. And I'm going to put Super Bowl. And so this is based on, this equation is on the Super Bowl and advertising. So I'm going to put this table up here. Now, here are my years. I'm going to do the same thing. 2007, I'm going to let that be year 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here is 10 years worth of data, and it's on the years. It's on the number of viewers in millions. So that's how many people were watching the game that year. And then notice the last is money spent. So think of this as the advertising on commercials. Okay, so we could make a prediction that the more money spent, the more people that watched. Maybe that has a relationship. We're not sure. So the first thing, let's talk about what do we notice. When they ask those sorts of questions, they're literally asking you to look at the data and see if you see any trends. So I look at this data, it looks like the number of viewers is increasing, and so is the amount of money. So I notice that both TV viewers and money spent increases over time. Years represent time. Okay, so there's more than one right answer to that. It's just what do you notice looking at the data? In part B, they would like us to determine correlation and equation for the year to be X and money spent to be Y. And they'd like us to round to the nearest hundredth. Okay, so for this particular problem, they don't want the middle column. They're asking us to look at the year and the money spent. So I'm entering this for X and money spent for Y. So I'm going to go back into data. I already had a 1 right here, so I can keep it, but I'm changing this to my value in billions. Notice that's billions dollars, not millions. So 8.71. And then next, I have year 2, but I'm entering 9.47. Year 3, but Y is now 9.56. Year 4, I have 8.87. In year 5, I have $10.15 billion on advertising. That's crazy. In year 6, I have 11.02. In year 7, 12.28. In year 8, 12.37. In year 9, 14.31. And in year 10, 15.53. All right, so I'm going to, after you've entered your data though, super simple. Remember you hit stat variance. It's calculating it. Then I'm going to scan all the way over. There's so much to A. There's my slope. So 44, it says 44.94, and I don't need to round it, plus B. So sorry, A, I got 44.94. Hundredth is the second place after the decimal. B, negative, so I'm going to erase my plus sign because it's negative 174.46. And R, if I scan one more over, I get a positive 0.65. So I would say that's moderate, positive. But I definitely know it's a positive. So you don't have to write moderate, but I would say it's moderate, but it is a positive correlation, meaning there is a relationship between the amount of money and the number of years that have gone by. Every year they spent more and more and more and more. So that would be the answers. Part C, now they want us to do the same thing in part B. They want us to do the correlation and equation of the line of best fit. And this time, TV viewers is X and money spent is Y. So they're looking, is there a relationship between the money? So the first we did money spent in years. Now they want us to do TV viewers and money spent. So I'm now going to be entering this for X and this for Y. So grab your calculator, hit data. We're just going to go down the line. So for X1, I'm entering 93.18. But my Y value is staying the same because money is still Y. So Y is staying the same. X2, 92.45, same Y. X3, 98.73. x4, 106.48, x5, 111, x6, 111.3, x7, 108.4, x8, 123.5, 9, 114.4, and my 10th value, 111.9. Okay, now I'm going to calculate, scan all the way over. This time I have a negative slope, so negative 6. If I round this, it becomes 6.5. Wait. X plus 703.48 and R 0.98, negative 0.98. This is a very strong negative correlation. Which is interesting because they're both going up. I wonder if I entered something wrong. It doesn't make sense. I feel like I entered something wrong in my calculator. My calculator looks right. We should have a positive correlation, so I don't know what's going on. It should have a positive correlation. Not sure how I messed that up. TV viewers and millions and money spent. Well, I messed that up somehow, but it's interesting that these had a positive and these had a negative correlation. That is the end of that section, and I apologize for the error at the end. I'm going to pretend you won't see that. And I'm trying to open my computer so I can stop this video.